6 flashes of light. That is what 4 astronauts watched erupt on the surface of the moon while floating in total silence, cut off from every other human being alive. 252,756 miles from Earth. No radio, no signal. No way to tell anyone what they were seeing. Just 4 people in a capsule smaller than your living room, watching rocks detonate on a dead world below them. And when they came back around and Mission Control finally heard their voices again, what they described did not match anything in any training manual, any simulation, any photograph ever taken. Not the colors, not the terrain, not the silence, and not the moment that stopped an entire room full of flight controllers cold. The moment when a Canadian astronaut quietly reached for the microphone and said a name that had nothing to do with orbital mechanics or mission objectives or scientific data. A name that made a commander press his lips together, close his eyes, and cry. I want to tell you about that moment. But first, I need to tell you something that changes the way you will look at the moon tonight. Because right now, as you are watching this, the moon is getting hit. Not occasionally, not rarely, constantly, while you sleep, while you work. While you are sitting here watching this video, rocks are slamming into the lunar surface at 40,000 miles per hour and exploding on contact. 6 of those explosions were witnessed by human eyes on April 6, 2026. And the reason that number should bother you has nothing to do with danger and everything to do with what it tells us about how wrong our picture of the moon has been for 400 years. Stay with me because this one earns it. The mission was called Artemis II. 4 astronauts: Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian astronaut Jeremy Hansen. They launched aboard the Orion spacecraft on top of the most powerful rocket NASA has ever built, the Space Launch System, and they did something no human crew had done since December of 1972. They flew to the moon. Not to land, not yet. This was what NASA calls a free return trajectory, a sweeping arc around the moon designed to test the hardware, stress the life support, push the navigation systems, and prove that Orion could keep 4 people alive and functional for a full 10-day mission envelope before trusting it with something bigger. The whole point of this flight was the vehicle. The science was secondary. The observations were not on the flight plan, which is exactly why what happened on April 6 matters so much, because the most important thing this mission revealed was never supposed to happen at all. Let me take you back to the moment it began. April 6, 2026, 8:35 in the evening, Eastern Time. Orion has been traveling for days. The crew is tired but wired. The way you feel when you are doing something that has never been done before in your lifetime, and you know it. They are roughly 4,000 miles above the lunar surface, which sounds like a long way until you realize that is close enough for the moon to fill the cabin windows, close enough to see individual craters, close enough that the terrain below them has texture, shadow, depth, color, things that no photograph ever quite communicates, because photographs are flat and the real moon is not, and then the sun begins to slide behind the moon. Not from their perspective on the ground the way you and I experience an eclipse. From behind, from space, from the other side of the blocking object itself. The crew of Artemis II was about to experience a total solar eclipse, not the way every human being in history has experienced. 1. Standing on Earth while the moon's shadow passes over them, but from inside the shadow, from the moon's own shadow, from a vantage point that has never existed in the entire history of human observation. Think about what that means for a second. Every solar eclipse photograph you have ever seen, every piece of footage, every description written by anyone who has ever lived, was created by someone standing on the sunlit side of the equation. The Artemis II crew was on the other side. They were sitting in the darkness that the moon itself creates, looking back toward the sun, watching the solar corona, the outermost atmosphere of our star, blazing outward around the silhouette of the moon in a ring of white fire that stretched 10 solar diameters in every direction. Reed Wiseman spoke first, and he said something that you do not expect from a test pilot. Test pilots are not known for poetry. They are trained to be precise and measured and clinical. Reed Wiseman looked at the solar corona wrapping around the black disk of the moon from behind and said it was transcendent. He said he needed to invent new adjectives. He said there were no words that existed in any language he knew that was sufficient for what he was looking at. Victor Glover, the mission pilot, the first black astronaut to fly a lunar mission, said something simpler and maybe more honest. He said humans probably have not evolved to see what we are seeing. And while that corona blazed in silence around the edge of the moon, while Wiseman searched for adjectives and Glover processed something his brain was not wired to categorize, something else caught their attention. Something on the dark surface below them. Small, sharp, brief, gone before you could be sure it happened. And then again. And then again. Flashes, bright, sharp, violet little points of light erupting on the darkened face of the moon and vanishing in less than a second. Not reflections, not instrument artifacts, not sense to noise. Impacts. Real, physical, kinetic impacts. Rocks arriving from interplanetary space and converting every joule of their energy into heat, light, and a new crater in less time than it takes you to blink. Wiseman reported the first one, then a second. By the time the flyby window closed, the crew had logged 6 confirmed impact flashes. 6 explosions on a world that most of us learn to think of as quiet. 6 detonations on a surface we treat like a museum exhibit. Something frozen, something preserved, something that stopped changing a long time ago. And here is the number that should stop you cold. NASA has a program called the Automated Lunar and Meteor Observatory, ALAMO, that has been watching the moon with telescopes from the ground since 2006. Patient, systematic, careful science. Over 2 decades of observation, that program detects roughly 20 confirmed impact flashes per year. 20 in 12 months. Across the entire visible face of the moon, the Artemis II crew saw 6 in a single hour. Now before your brain does the math and multiplies that out and arrives at a number that sounds alarming, I want to be honest with you about why that direct comparison is both misleading and important. Because the truth here is more interesting than the scary version. The Artemis crew was not observing under normal conditions. They were observing under conditions that have never existed before in the history of human astronomy. No atmosphere between their eyes and the surface. No light pollution. No turbulence bending the photons on their way to the detector. The sun was entirely blocked, meaning the near-side surface was as dark as it ever gets, lit only by the faint reflected glow of Earth itself, what astronomers call Earthshine, just enough light to see the surface, not enough to drown out a flash. And they were 4,000 miles away, instead of 239,000. The moon was not whispering, it was right there. Every faint event that would have been swallowed by atmospheric noise from the ground was visible to them in crisp, unfiltered detail. So you cannot directly compare their detection rate to the ground-based rate and conclude the moon is 2,000 times more active than we thought. That would be wrong. But here is what you absolutely can conclude. And this is the part that planetary scientists have been saying for years in journals that most people never read. The ground-based detection rate is not the impact rate. It is the detectable fraction of the impact rate, as observed through Earth's atmosphere during the restricted windows when conditions are acceptable, with equipment sensitive enough to register only the brightest events. It is the floor, the basement, the minimum possible count below which the true rate cannot fall. The Artemis II crew, for one brief hour, lifted the floor. They saw the moon without the filter, and the moon without the filter is a very different place than the moon we have been constructing in our minds for 4 centuries. I want to tell you exactly what is hitting it, because the physics of this are genuinely extraordinary, and they will completely change the way you understand what a shooting star is. On Earth, when a grain of sand-sized particle comes screaming in from interplanetary space at 40 kilometers per second, it does not reach the ground. It hits our atmosphere about 100 kilometers up and begins compressing the air in front of it so violently that both the air and the particle heat to thousands of degrees in milliseconds. That streak of light you see on a clear summer night is not a rock burning. It is the atmosphere itself being compressed into plasma by something moving faster than our brains are really built to process. The particle is usually vaporized entirely long before it gets anywhere near you. Earth's atmosphere is a planetary defense system that has been running for 4.5 billion years, and you have never once had to do anything to maintain it. The moon has no version of that. None. The lunar atmosphere, if you could call it that, has a total mass of about 10 metric tons. Earth's atmosphere masses 5 quadrillion metric tons. The moon's envelope of gas is so thin that molecules almost never collide with each other. It is called an exosphere. It provides zero protection against incoming debris. Zero. Not a little. Zero. When something approaches the moon from space, it hits the surface at full cosmic velocity, unmodified, undimmed. exactly as fast as it was when it was drifting through the solar system before the moon's gravity started pulling it in. We are talking anywhere from 11 to 70 kilometers per second, depending on the particle's origin and approach angle. At the upper end of that range, you could cross the entire continental United States coast to coast in under a minute. You could circle the whole planet in less than 10 minutes. And when something moving that fast hits solid rock, it does not bounce. It does not gradually decelerate. It stops in microseconds across a distance measured in millimeters. All of that kinetic energy, every last joule of it, converts instantaneously into heat, pressure, and light. The meteoroid vaporizes. The rock around it vaporizes. Not melts, vaporizes. Goes directly from solid to superheated plasma. A shockwave radiates outward through the regolith faster than sound travels in rock. A crater is excavated not over seconds, but in milliseconds. And at the center of it all, for a fraction of a second, there is a flash. A burst of thermal radiation from material heated to tens of thousands of degrees. Brief, enough to vanish before your brain finishes processing it. Violent enough to be visible from 4,000 miles away through the vacuum of space. That is what Reed Wiseman saw. That is what lit up the dark surface below Orion. Not alien activity. Not equipment malfunction, not some unusual spike in lunar seismicity, just the solar system doing what it has been doing to every airless body in it since the beginning. Just rocks arriving, paying the toll, and going silent. In 2013, ground-based observers recorded an impact flash bright enough to be visible to the naked eye for nearly a full second. It made international news. Follow-up imaging by the Lunar Reconnaissance Orbiter confirmed a fresh crater at the site, roughly 18 meters across, punched in an instant that most of humanity slept through. The estimated energy release was equivalent to about 5 tons of TNT, a walnut-sized rock producing an explosion that would flatten a city block. And that was not a rare event. It was simply one of the ones bright enough for us to catch from 239,000 miles away through an atmosphere that was actively working against us. The Artemis II crew was watching the normal version of that. The version that happens every hour, every day, at rates our telescopes have been systematically unable to count. Does that change anything for you? Drop your answer in the comments because the responses to this question are genuinely fascinating. Some people hear this and feel the moon become more alive somehow. Other people feel uneasy. And I think both reactions are completely valid. Here is what I want you to hold on to before we go further. The moon did not change on April 6th. The bombardment did not spike. There was no unusual meteor shower, no comet close encounter, no temporary elevation in the flux. What changed was the measurement. What changed was the observer and the observer's position. For one brief, unrepeatable hour, 4 human beings were in a place where the filters that normally stand between us and the moon's reality were completely absent. And the view from there is startling not because it is new, but because it is accurate. Because it shows you the thing you were always looking at, finally without the veil. And now I need to tell you why this matters beyond astronomy. Because humanity is not just curious about the moon. We are planning to move there. Artemis III will land astronauts on the lunar surface, targeting the South Pole, probably within the next few years. The plans that come after that are more ambitious. Permanent outposts. Crew rotations measured in months, then years. Habitat, laboratories, resource extraction facilities, mining the water ice that sits frozen in permanently shadowed craters at the poles. The long-term vision written into planning documents and budget justifications and international partnership agreements across a dozen space agencies is a continuous human presence on the moon. People living there, not visiting, living. And every one of those plans is calibrated against our best estimate of what the lunar environment actually demands from the structures meant to keep those people alive. Here is where the Artemis II observation becomes something more than a cool data point. A recent study estimated that a lunar surface structure with an exposed area comparable to the International Space Station would be struck by between 15,000 and 23,000 micrometeoroids every single year. 23,000, not large visible impacts. Micrometeoroids, particles typically smaller than a millimeter, sometimes smaller than the width of a human hair, moving at the same hypervelocity speeds as their larger cousins, because speed in interplanetary space is governed by orbital mechanics, not by mass. 23,000 impacts per year on a single structure is not a threat you design around once and then move on from. It is a weather system. a permanent, invisible, unstoppable storm that operates every hour of every day, depositing a little damage here and a little more damage there. Too small to trigger any sensor, too small to see, quietly accumulating until something crosses a threshold you did not know you were approaching. This is what the visible flashes the Artemis crew saw were actually telling us. Not that the dramatic large impacts are the problem. They are the obvious ones, the loud ones, the ones you plan for because they are impossible to ignore. The real engineering challenge is the vast invisible population beneath them. For every flash visible from 4,000 miles away in orbit, there are thousands of events. Too faint to see, but perfectly capable of pitting optical coatings, weakening structural joints, perforating thermal blankets, and introducing microscopic cracks into pressure vessel walls over the course of a decade. We have physical evidence of exactly this from the International Space Station. After decades in low Earth orbit, the exterior surfaces of ISS modules show thousands of micrometeoroid and debris impact craters, some large enough to see clearly during spacewalks. Cupola windows have been chipped by particles estimated to be only a few thousandths of a millimeter across. Handrails show erosion patterns consistent with years of hypervelocity exposure, and the ISS has it comparatively easy. It orbits inside Earth's magnetic field, which deflects a significant fraction of the charged particle flux. It operates in an environment where the meteoroid flux is lower than the interplanetary environment the Moon inhabits. On the Moon, there is no magnetic field assistance. The flux is higher, and the exposure would be continuous for anyone planning to stay for months or years. The standard engineering response to this threat is something called a Whipple Shield, named after the astronomer Fred Whipple, who proposed the concept in the 1940s. Rather than building one thick wall strong enough to stop incoming particles directly, he built two or more thin walls separated by a gap. When a hypervelocity particle strikes the outer bumper, it punches through, but in doing so, it and the wall material both shatter and vaporize, converting a single concentrated projectile into an expanding cloud of slower, more diffuse debris. By the time that cloud reaches the inner pressure wall, the energy has been spread across a wide area, and the inner wall can absorb it without being penetrated. Modern Whipple Shield designs have evolved considerably, and their performance is genuinely impressive. Well-designed configurations can intercept an estimated 99.99.99.97% of incoming particles at design velocities and angles. That sounds almost absolute, but nearly absolute is not absolute, and the mathematics of long-duration exposure are unforgiving. The remaining fraction, applied to 23,000 impacts per year, still means a statistically meaningful number of penetration events across a 10 or 20-year mission timeline, and this is before accounting for the possibility that the true flux is higher than the models currently suggest. Because the models are built on observations from the ground, from the same Earth-based systems that Artemis II just demonstrated, we're only seeing a fraction of what was actually happening. If the Artemis observation exposed a significant undercount at the bright detectable end of the size distribution, the natural question is whether that same blind spot extends into the micrometeoroid range. If it does, if the flux numbers feeding the engineering calculations are even modestly optimistic, then the safety margins built into the designs may be thinner than the engineers who built them believe. This is not an argument for cancelling lunar exploration. It is an argument for taking the Artemis II data seriously and using it to drive the design of dedicated orbital impact monitoring systems that can do continuously what the crew did accidentally for 1 hour. To replace our Earth-centric picture of the lunar environment with measurements gathered from cislunar space, where the filters are off and the signal is clean. Because the gap Artemis II revealed is not a gap between the old Moon and a newly dangerous one. The Moon was always doing this. The gap is in human perception. The gap is what happens when you watch an overwhelming phenomenon through an instrument too limited to capture its full scale and then mistake the instrument's limitations for the phenomenon's reality. And now I want to tell you about the far side, because the crew saw things there that no camera has ever captured in quite the same way, and some of what they described forced scientists to stop and reconsider what they thought they understood about the Moon's most fundamental geological asymmetry. As Orion swung behind the Moon and the communications blackout began, as the signal went dead and mission control went quiet and the crew floated in the most complete isolation any human beings have ever experienced, they were looking at a hemisphere of the Moon that no living person had seen with their own eyes since Apollo 17 in December of 1972, more than 53 years. An entire generation born and grown and in some cases grown old without a single human being making this particular journey. Christina Koch was the first to comment on the colors. She had expected the moon to look the way it looks in photographs. Grey, silver, the familiar monochrome palette of every image ever taken by any robotic spacecraft or telescope. Instead, she said the more she looked at it, the browner and browner it looked. The crew reported shades of brown and blue, greenish tones in the highlands, subtle mineral variations that played differently under continuously shifting illumination as Orion moved through its arc. Different astronauts looking at the same features from slightly different angles perceived slightly different colors, and that discrepancy was not a problem. That was exactly the science. Here is why human eyes matter in ways that cameras cannot replicate. And this is something NASA's lunar science lead Kelsey Young explained before the flyby in terms that I think most space reporting completely missed. A camera captures light at fixed wavelength bands. It is like playing a piano with only certain keys available. The human eye perceives a continuous spectrum. It detects gradations between the bands that a satellite instrument is not designed to measure. And crucially, the human eye adapts in real time to changing illumination. As Orion moved, the angle of sunlight on the surface changed constantly. The same crater looked different from one minute to the next as the light hit it from a new direction. A trained human brain processes those differences instantaneously, flagging anomalies, making connections, noticing things that a camera image taken from directly above under steady illumination would never reveal. Young used an analogy that stuck with me. She said, think about a sandbox. Change the angle of light on sand, and you either see color and albedo, or you see topography and morphology. You can tell whether a surface is rough or smooth, reflective or dull, red or gray, depending entirely on where the light is coming from. An orbiting satellite captures the surface under one set of lighting conditions per pass. The Artemis II crew saw the same features under continuously changing illumination, and their brains processed the differences in real time. The most striking observation from the far side was not the colors, though. It was the absence. The near side of the moon, the face you look at every night, is roughly 31% Maria. The dark basaltic plains formed by ancient lava flows that flooded the low-lying basins billions of years ago. Smooth, dark, volcanic. The far side is less than 1%. Instead, it is battered ancient highland terrain, pale and relentlessly cratered. A surface that has been hammered for 4.5 billion years without the volcanic resurfacing that smoothed out so much of the near side. Craters on top of craters on top of craters, stretching to every horizon. The reason for this dramatic asymmetry runs deeper than the surface. Much deeper. The far side crust is up to 20 kilometers thicker than the near side crust. That extra thickness meant that when asteroids cracked the crust on the far side, the magma beneath could not easily reach the surface. The lava stayed underground. On the near side, the thinner crust cracked all the way through and molten rock flooded the impact basins, creating the dark plains we see today. But why is one side's crust thicker? This is where it gets genuinely strange and where some of the most exciting science from recent years comes in. The near side contains a geological region enriched in radioactive elements, uranium, thorium, potassium, elements that generate heat as they decay. For billions of years, this radioactive furnace kept the near side interior warm, powered the volcanism, flooded the basins, shaped the familiar face. The far side got none of that heat source. A 2025 study published in Nature confirmed this interior temperature asymmetry using tidal response data, measuring how the moon deforms slightly in response to Earth's gravitational pull. The near side mantle is measurably warmer than the far side mantle. The difference is baked into the moon's interior down to its deepest layers, and the Chang'e 6 mission, China's first ever sample return from the far side of the moon in June of 2024, added the most practically consequential data point of all. The far side samples contained less than 2 micrograms of water per gram of rock. The near side can contain up to 200 micrograms per gram. The far side is, for practical purposes, bone dry. And for anyone planning a long-term human presence on the moon, water is not just important. Water is everything. It is life support. It is rocket fuel. It is agriculture. Without water, you are entirely dependent on resupply from Earth, which is ruinously expensive and operationally fragile. This is a major reason why the lunar South Pole has become the focus for Artemis surface missions and all future human presence. because the South Polar permanently shadowed craters may harbor ice deposits that change the economics of everything. Now I want to tell you about Victor Glover and the Terminator, because his description of it is one of the most vivid accounts of any astronomical observation I have ever read. The Terminator is the line on the moon's surface where sunlight ends and shadow begins. From Earth it looks like a smooth, graceful curve. From 4,000 miles above the surface, it looks like the edge of a world being consumed. When the sun is at an extreme angle, nearly parallel to the ground, it casts impossibly long shadows. Every ridge, every hill, every crater rim throws a shadow that stretches for kilometers. Features invisible in overhead lighting leap out with three-dimensional clarity. The Terminator is a revealer. Victor Glover floated to the window and became almost inarticulate with excitement. He radioed mission control and said he wished he had more time to just sit there and describe what he was seeing. The Terminator was the most rugged he had ever seen it from a lighting perspective. There were islands, he said, islands of terrain completely surrounded by darkness, mountain peaks that caught the last rays of sunlight while the valleys around them had already fallen into night. He said he felt like he had gone science fiction. He compared specific peaks near the Terminator to snow-covered mountains, not because there was snow, the moon has no surface water, but because fresh unweathered rock reflecting sunlight at a shallow angle produces a whiteness so extreme against the shadowed valleys that it looks exactly like a mountain range in winter. That observation matters scientifically because it tells you about where the surface is geologically young, where recent impacts have exposed fresh material that has not yet been darkened by millions of years of solar wind bombardment. Kelsey Young's response from the science evaluation room in Houston was unguarded. She said she literally saw fist pumps in the air when Glover described the Terminator. She said, "That is the kind of observation that humans are uniquely able to contribute." I want to step back here and ask you something directly. Do you think the risk of building permanent habitats on the moon is worth it? Not visiting, not planting a flag and leaving, but actually living there. Put your answer in the comments. I read every single one, and the conversation down there is genuinely one of the best parts of this channel. Because I think when you sit with everything the Artemis II crew witnessed, the impacts, the far-side geology, the radiation environment, the sheer physical hostility of the place, the question of why we would go becomes urgent in a new way. And I think the answer is more complicated and more interesting than either the pure science justification or the pure human adventure justification would suggest by themselves. Let me tell you about the blackout. Because for 40 minutes on April 6th, the 4 people aboard Orion were more alone than any human beings in the recorded history of our species. At 6:44 in the evening, Eastern Time, Orion slipped behind the far side of the moon. One moment, the Deep Space Network, NASA's chain of massive antenna stations in California, Spain, and Australia, was tracking them, receiving telemetry, monitoring life support, listening to their voices. The next moment, nothing. The moon's bulk blocked every radio signal, every data stream, every connection between the crew and the rest of humanity. Mission control went quiet. Flight Director Judd Freeling had warned everyone this was coming. He had told his team that physics would take over and that physics would absolutely bring them back, but physics does not talk back. And for 40 minutes, 8 billion people on Earth had no way to know what was happening aboard Orion. The crew had trained for this. They knew the blackout was coming, and they knew its duration. But there is a difference between knowing something intellectually and experiencing it in your body. And what the crew experienced during those 40 minutes was something no simulation ever fully replicates. They experienced the disappearance of Earth. It is called Earthset. As Orion swung behind the far side, the crew watched their home planet drop below the lunar horizon and vanish. One moment Earth was there, a bright blue marble in the black. The next moment it was gone, swallowed by the edge of the moon. Every city, every ocean, every person they had ever met, every place they had ever been, hidden behind 4,000 miles of lunar rock. Christina Koch spoke about it during a broadcast from the spacecraft before the crew's return. She said one of the biggest highlights of the entire trip was coming back from the far side and getting the first glimpse of planet Earth again, after being out of communication for about 45 minutes. She said it just reminds you what a special place we have. Notice what she did not say. She did not describe a scientific observation. She did not list a data point. She described the return of something that most of us never think about, the simple, continuous presence of our world in our awareness. For 40 minutes it was gone, and its absence was felt. During the blackout, the crew kept working. They observed the far side terrain. They photographed features no human had seen this clearly since 1972, and Jeremy Hansen reported seeing 2 impact flashes during those 40 silent minutes. 2 explosions on the moon witnessed by no one else alive. 4 people, and the darkness and the physics and the small violent universe below them. They also celebrated. Hansen had brought maple cream cookies from Canada. The crew shared them in microgravity behind the moon, floating in a capsule smaller than a sedan, eating cookies while rocks exploded on the world beneath them. Wiseman called it surreal. It was the kind of moment that space reporting tends to overlook in favor of the dramatic and the technical, but I think it is exactly the kind of moment that makes these missions human in the deepest sense. 4 people doing the most extraordinary thing any living person had done in 50 years, and pausing to share a snack. When Orion emerged from behind the moon at 7,024 in the evening, and the Deep Space Network reacquired the signal, the first thing the crew had to report beyond the impact flashes was that they had broken a record in the silence. At 7,007, still behind the moon, still in blackout, they reached their maximum distance from Earth, 252,752 miles. The farthest any human being has ever been from home. They broke the record held by the Apollo 13 crew, Jim Lovell and his crewmates, who reached 248,655 miles during their desperate slingshot maneuver in 1970. Artemis II surpassed it by 4,000 miles. In total silence, with no cheering from mission control and no live broadcast, and no one watching except the 4 of them. Jeremy Hansen marked the moment with a sentence that I think deserves to be remembered. He said, "We most importantly choose this moment to challenge this generation and the next, to make sure this record is not long-lived." He was not long-lived. He was issuing a challenge. The record exists to be broken. And every single person watching this video is part of the generation he was challenging. Now I need to tell you about Jim Lovell because the thread that connects 1968 to 2026 is one of the most beautiful things about this entire story, and it involves a message recorded by a 97-year-old man 2 months before he died. Jim Lovell flew to the moon twice. The first time on Apollo 8 in December of 1968. He and Frank Borman and Bill Anders became the first human beings to leave Earth orbit, travel to another world, and see the far stranger as happening something Galax. It was Christmas Eve. They orbited 10 times. Bill Anders took the Earthrise photograph, the image that National Geographic would later call one of the 100 most influential photographs in history, the image that many people credit with helping spark the environmental movement, the image that showed humanity its own fragility for the first time. The second time, Apollo 13, April of 1970. An oxygen tank exploded 2 days into the mission. The spacecraft was crippled. Lovell and his crew used the lunar module as a lifeboat. They swung around the far side of the moon, using its gravity to slingshot back to Earth. Their survival was uncertain. They made it back alive, barely, after one of the most harrowing 72 hours in the history of human spaceflight. Lovell lived for another 55 years after that. He watched the shuttle program. He watched the space station being built. He watched Mars rovers sending back photographs. He watched the Artemis program take shape, and 2 months before his death, in August of 2025, at the age of 97, he sat down and recorded a message for the crew that would finally break his distance record. On the morning of the flyby, Mission Control beamed it up to Orion. The crew heard the voice of a man who had orbited the moon on Christmas Eve and nearly died trying to get back from it. A man who had seen Earthrise with his own eyes and carried the memory for 57 years. A man who understood what the Artemis II crew was about to experience because he had been there first and could only imagine what it looked like now. "Hello, Artemis II, he said. "This is Apollo astronaut Jim Lovell. Welcome to my old neighborhood. It is a historic day, and I know how busy you will be. But do not forget to enjoy the view." The crew also carried Lovell's original Apollo 8 Silk mission patch aboard Orion, the same patch that had flown to the moon in 1968, now flying to the moon again in 2026 in different hands, but on the same journey. Wiseman held it up and said it was a real honor to have it on board. "Let us go have a great day." And then they went to work, because the overview effect that was rewiring their perspective simultaneously, the emotional weight of the Earthrise and the blackout in Lovell's voice, none of it suspended the science. The 2 things ran in parallel the entire time: wonder and rigor, awe and data, the way they always do when you send the right people to the right place. NASA had prepared approximately 35 geological features for the crew to observe and photograph during the flyby. The targets range from the Oriental Basin, a nearly 600-kilometer-wide impact crater straddling the near and far sides, formed 3.8 billion years ago, and preserving dramatic concentric ring structures that reveal the physics of giant impacts, to Hertzsprung crater on the far side, older and more degraded, which when compared to Oriental gives scientists a visual time-lapse of how lunar features evolve across geological time. On the Moon without weather, without plate tectonics, without rivers or wind, or any erosional force beyond the patient accumulation of smaller impacts, the craters from 4 billion years ago are still there. They just look tired. The crew observed the Glushko crater with its striking ray system. Bright streaks of ejected material extending more than 500 kilometers across the surrounding surface. They saw Rhina Gamma, one of the most mysterious features on the entire Moon, a bright tadpole-shaped marking on the surface that has baffled scientists since it was first observed through primitive telescopes in the 1600s. Not a crater, not a volcanic deposit, not any geological feature that ordinary processes would explain. A swirl, a painted brushstroke on the dark basalt, sitting directly on top of one of the strongest magnetic anomalies on the Moon. The story of Rhina Gamma and what it tells us about the Moon's vanished magnetic history is worth a full video on its own. The short version is this. The Moon once had a global magnetic field generated by a dynamo in its liquid core, just like Earth's. As the Moon cooled and its core solidified, the dynamo died. The global field collapsed, but scattered across the surface. Remnant magnetic patches survive. Fossils of the ancient field lopped into specific formations of iron-bearing minerals, and where one of those magnetic patches exists, it provides a weak local shield against the solar wind, the constant stream of charged particles blowing outward from the sun. The shielded surface experiences less space weathering, less darkening, and stays brighter than the surrounding terrain. The result is a visible surface marking whose shape corresponds to the underlying magnetic field. A bright swirl, painted not by any artist, but by the physics of a dead planetary dynamo reaching up through kilometers of rock to leave a signature on the surface above it. The crew flew over Rhina Gamma and described it from an angle and under illumination that no satellite have ever replicated. Their observations will be analyzed for months, but the mystery itself runs far deeper than any single flyby can resolve. It waits for a lander. For a magnetometer placed directly on the surface, for the kind of close contact measurement that can only come when something or someone is actually there. Then the crew saw something they did not expect to feel. While scanning the lunar surface with their naked eyes and cameras, looking for their assigned targets, but also just looking, letting their human pattern recognition brains do what they were built for, 2 craters caught their attention. Small, fresh, bright. Unnamed. Jeremy Hansen reached for the microphone. A number of years ago, he said, his voice still professional but carrying something underneath it, we started this journey, and in our close-knit astronaut family, we lost a loved one. He paused. Her name was Carol, the spouse of Reed, the mother of Katie and Ellie. Carol Taylor Wiseman was a neonatal intensive care nurse. She spent her career caring for the smallest and most fragile human beings, premature infants in their first terrifying days of life. She died of cancer in 2020 at the age of 46. Reed Wiseman has been raising their 2 daughters alone since. Hansen described the location of the second unnamed crater, on the boundary between the near and far sides of the Moon, near the Glushko crater. A bright spot, he said, visible from Earth at certain times during the Moon's transit. And then he said the words, "We would like to call it Carol." As he spoke, Wiseman reached over and put his hand on Hansen's shoulder. His eyes were wet. He pressed his lips together and nodded, the controlled expression of someone using every tool they have to hold something in and not quite succeeding. And then the 2 men embraced. Not a handshake, not a professional pat. A real hug. The kind that happens when grief and love and distance collapse into a single moment. And Koch and Glover joined them. All 4 astronauts pulled together in a floating embrace, wiping tears, holding each other in silence. 252,000 miles from home. Mission control went quiet. The internet responded the way the internet sometimes does when something real breaks through. One comment I saw that stayed with me said, "Sounds like Carol was love to the moon and back, literally." Another said her daughters can look to the night sky and find their mom. From now on, if the International Astronomical Union approves the naming, which the crew will formally submit after the mission concludes, there is a bright spot on the moon called Carol, a spot their daughters can find with a backyard telescope, a spot that existed before their mother died, a spot that will exist long after everyone alive today is gone. This moment matters beyond its emotional power. It matters because it is the argument for sending humans into space, distilled into a single act. Robots do not name craters after dead wives. Robots do not weep. Robots do not float in a group embrace with tears clinging to their cheeks in microgravity. The emotional resonance of a mission is not separate from its scientific value. In many ways, it is what makes the scientific value legible to the civilization funding it. Numbers and data fill journals. Moments like this fill hearts, and hearts are what sustain the will to keep going. The first crater the crew named was called Integrity, after the spacecraft itself. The name, Wiseman explained, embodied the foundation of trust, respect, candor, and humility that had defined their years of training together, and Carol sat beside it, bright and visible, on the boundary between the side of the moon that faces us and the side that hides. I want to talk about what the crew's bodies were experiencing during all of this, because there is another dimension to what it means to fly beyond Earth's protection that most mission coverage completely skips, and it connects directly to the most unsettling thing Buzz Aldrin reported on Apollo 11, that nobody talked about for years afterward. He was floating in the command module with his eyes closed, trying to sleep, when he saw a flash of light. Not from the cabin, not from any indicator. Inside his eye, a brief streak of white appearing and vanishing behind his closed eyelid. He opened his eyes. Nothing. He closed them again. Another flash. Every subsequent Apollo crew reported the same phenomenon. Every astronaut who traveled beyond Earth orbit and spent time in darkness saw them. They came in shapes, spots, streaks. Occasionally a distinctly colored bloom of light. Apollo 14's Edgar Mitchell described one as blue with a white cast, like a blue diamond. The average rate was roughly one flash every 3 minutes during dark-adapted periods, and they were more frequent on the outbound trip, the transit to the moon, than on the return. The astronauts were not hallucinating, they were being shot by cosmic rays. Cosmic rays are high-energy charged particles, mostly protons and atomic nuclei, accelerated to velocities approaching the speed of light by some of the most violent events in the universe. Supernovae, black holes, the collision of galaxies. They have been traveling for millions of years across unimaginable distances, and some of them end up passing through our solar system and through any spacecraft unfortunate enough to be in the way. On Earth, we are largely protected by two shields. The magnetosphere, the magnetic field generated by our planet's molten iron core, deflects the majority of incoming charged particles, and the atmosphere absorbs most of what makes it through. Neither of these things exist for anyone traveling to the moon. When a cosmic ray passes through a human eye at near light speed, it interacts with the material in ways that our brains interpret as light. The leading explanations involve Cherenkov radiation, the flash produced when a particle moves faster than the local speed of light through the vitreous humor of the eye, or direct ionization of retinal cells as the particle deposits energy passing through, or, most unsettling of all, direct interaction with the visual cortex of the brain, producing the sensation of seeing something without ever touching the eye at all. During Apollo 16 and 17, NASA tested this directly with a device called ALF-MED, a helmet lined with photographic emulsion plates that recorded particle tracks while the astronaut wore it and reported flashes. The correlation was suggestive but not conclusive. The science is still developing. What is not in doubt is that the flashes are real. They are caused by ionizing radiation, and for the Artemis II crew, the radiation environment was significantly more intense than anything an ISS astronaut experiences. A paper published in Science in January of 2026 detailed the deep space radiation challenges facing the Artemis crew. Beyond Earth's magnetosphere, they faced the Van Allen belts during transit, solar particle events capable of spiking to dangerous levels within hours, and the constant background drizzle of galactic cosmic rays arriving from every direction at all times. The long-term health consequences for this specific crew will be monitored for years. Studies of Apollo astronauts have shown elevated cardiovascular disease rates compared to astronauts who never left low Earth orbit. The sample size is small. Only 24 humans have ever gone beyond Earth orbit before Artemis II, and all of them were Apollo men. Christina Koch is the first woman to travel this far. Victor Glover, the first black astronaut on a lunar mission, Jeremy Henson, the first non-American. The data their bodies generate over the coming years will be among the most scientifically important health data in the history of spaceflight. The flashes in their eyes are not a curiosity. They are a symptom, a visible, perceptible symptom of invisible damage. Every flash represents a particle crossing the threshold of their skull at nearly the speed of light, depositing energy, breaking molecular bonds, and moving on. You can see it happening. You cannot stop it. This is the context in which the plan to build permanent habitats on the moon needs to be understood, not just the meteoroid threat, not just the construction challenges, but the radiation environment, the psychological weight of isolation, the physiological demands of long-duration exposure to a world that has no interest in keeping you alive. And yet the crew came back describing transcendence. Let me tell you about the eclipse. The proper eclipse, because I have been circling it since the beginning of this video, and it is time to go there directly. At 8:35 in the evening of April 6th, from Orion's perspective, the sun began sliding behind the moon. Totality began, and it lasted until 9:32, 57 minutes, nearly an hour. On Earth, the longest total solar eclipse possible is just over 7 minutes. People fly across oceans for those 7 minutes. They weep. They say it changed their lives. The Artemis II crew experienced roughly 8 times that duration in a configuration no human being has ever occupied. From their position, the moon did not just block the sun, it created something the human visual system has no template for: the solar corona, the outermost atmosphere of the sun extending millions of miles into space. Normally invisible because the sun's surface is so overwhelmingly bright, it drowns everything else out, wrapped almost entirely around the black disk of the moon, in structures and formations that ground-based eclipse observers have never seen with equivalent clarity. No atmosphere to scatter the photons, no turbulence to blur the edges, no humidity, just the vacuum of space between their eyes and the corona of a star. Victor Glover described the streamers, the long filaments of solar plasma reaching outward like luminous threads into the darkness. He compared them to baby hairs. Fine, delicate, impossibly bright, and then he found the comparison that captured it. If you've ever seen the spotlight off the top of the Luxor Hotel in Las Vegas, he said, this looks like what that wants to be when it grows up. The Luxor runs a 42 billion candle power beam visible from 100 miles away on a clear night. Glover was saying the corona made it look like a flashlight. During the eclipse, the crew observed several planets, Venus and Mars and Saturn and Mercury, all visible against the darkened sky. They searched for zodiacal light, the faint glow of sunlight reflected off interplanetary dust filling the plane of the solar system. They looked for electrostatically levitated lunar dust, a phenomenon first detected during Apollo when astronauts noticed a mysterious glow along the lunar horizon at sunrise. And they observed Earth. Reed Wiseman had not anticipated how bright it would be, with the sun blocked and the crew's eyes fully dark adapted to the conditions. Earthshine, the reflected light from our own planets illuminating the moon's night side, was startlingly vivid, bright enough to see surface features on the darkened lunar terrain. The reflected glow of our home planet, 8 billion people's world, crossing 250,000 miles of vacuum and painting the surface of another world in a faint blue-white wash visible to the naked eye.